There, Mr. Sutton here, bringing you the Algebra 2 5-3 Part 2 homework solutions on graphing radical functions. In this one, we're going to focus on the odd functions as well as writing functions of transformations with radicals. On this problem, we're trying to graph this g function. First, let's figure out what transformation is happening. This -8 inside the cube root function is doing two things. The negative gives us a horizontal reflection, and the times 8 is giving us a horizontal shrink. So both those things happening. Let's do the parent table now for the cube root function. This is going to be -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. Just those 5 points we use every time we do a cube root. And for the g function, horizontally, if we're doing a horizontal shrink and reflection, we're going to be multiplying the x values by the reciprocal of whatever's in here, so -1/8 times x. There's nothing happening outside the function, so the y value is going to stay the same. So we have -1/8 times -8. That's going to give us +1, which is kind of nice. -1/8 times -1 gives us +1/8. 0 is still 0. 1 becomes -1/8. And 8 becomes -1. For the y values, we still have -2, -1, 0, 1, and 2. All right, so graphing all of that out, let's start up here. We have 1, -2 right there, and then 1/8, -1. It's pretty close to the y-axis. 0, 0 is here. -1/8, 1 is somewhere around here, and then -1, 2 right up there. And then just kind of connect those in an S-shaped sort of kind of thing, and there you go. For this problem, let's look at the transformations that are happening on this cube root function. The +6 inside is shifting us 6 to the left. The 1/2 outside is giving us a vertical shrink. So both of those things happening at the same time. The parent table, again, we have -8, -2. -1, -1, 0, 0, 1, 1, and 8, 2. For the f function, since we're going left 6, we're going to have to do x -6 for those x values. And the vertical shrink makes us do 1/2 times the y values. So let's subtract 6 from all of our x's. We have -8 minus 6 is -14. -1 becomes -7. 0 becomes -6. 1 minus 6 is -5. And 8 minus 6 is 2. Now for the y values, we're multiplying these all by 1/2. So -2 becomes -1. -1 is now -1/2, or -0.5. 0 is still 0. 1 is now 0.5, and 2 becomes 1. All right, if we're going to graph all these to go from -14 to 2, I'm probably going to need to make my x values go by 2's at least. And I'll keep my y values the same. I don't mind going half a grid line there. So we've got -14, -1 is right there. And then -7 is about there. -0.5 is there. We've got -6, 0 is right on the x-axis. -5, 0.5 is right about there. And 2, 1, that one's a little bit easier. It's right up there. So just doing my s through all of those, there we go. For this problem, we're trying to graph -3 times x plus 1 to the 1/3 power. A good way to start this would be to turn that fractional exponent into a radical that we're a little bit more used to. So this is actually the cube root of x plus 1 with that -3 out there. And in terms of transformations, this -3 out here is doing two things. We have a vertical reflection with the negative and a vertical stretch with the ×3. The +1 inside is giving us a horizontal shift 1 to the left. So vertical reflection, stretch, and translation left 1. All right, so let's do our parent table. It's just the cube root function. So we have -8, 2, -2 rather, -1, -1, 0, 0, 1, 1, and 8, 2. For the g function, since we're going 1 to the left, that's going to be x -1 for that new rule. For the y values, we're going to be multiplying those as it looks like out here by -3. So for my new x values, -8 minus 1 is -9. -1 becomes -2. 0 is now -1. 1 minus 1 is 0, and 8 minus 1 is 7. Negative 3 times my y values gives me, let's see here, negative 2 becomes 6, negative 1 becomes 3, 0, 0. Now we have 1 times negative 3 is negative 3, and 2 times negative 3 is negative 6. Graphing all that out, looks like I made my grid lines in both directions go by 2's just to make sure I can fit everything. So our first point, we've got negative 9 comma 6, which is up here. Then negative 2 comma 3 is right there. And then negative 1 comma 0 right on the x-axis. And now we have 0 comma negative 3 for a y-intercept. And then 7 comma negative 6 down here. And then let's just draw our cube root function through all of these points. On this problem, we've got a fifth root of negative 32x plus 3. So there's a fair amount going on in this one. Let's start by writing out what the transformation should be on the fifth root function. So the negative 32x in here, that's giving us, the negative gives us a horizontal reflection. The times 32 actually gives us a horizontal shrink by a factor of 1 over 32. The plus 3 outside gives us a shift, a translation of up 3. So horizontal shrink and reflection, translation up 3. So my g of x, or actually let me write my fifth root parent table first. So I'm going to have negative 2 to the fifth power, and negative 2 is my first point. So that's going to be negative 32 and negative 2. And then I'm going to have the other usual suspects. So negative 1, 0, 0, 1, 1. And then the counterpart to negative 32, negative 2, which is positive 32, positive 2. So let me make my g table now. The new rule for x is going to be negative 1 over 32 times x. It's opposite of what it looks like there. And then for the y values, we're just adding 3 to those. So multiplying negative 1 over 32 by all my original x values, negative 32 times negative 1 over 32 just gives me 1, which is kind of nice. This negative 1 is becoming a positive 1 over 32. 0 is still 0, very nice. This 1 becomes a negative 1 over 32, and 32 times negative 1 over 32 is negative 1. Now adding 3 to my y values, negative 2 plus 3 is 1, negative 1 becomes 2, 0 becomes 3, 1 becomes 4, and 2 plus 3 is 5. All right, now to actually get this on a graph with any kind of accuracy, I think I'm going to have to make my grid lines on my x values go by at least 1/2, if not something even smaller. So here's what I've got for my grid. So I'm going by 1/2 there, and then I've got it divided up a little as well. So first off, we've got 1, comma 1, that's my first point, and then 1 over 32, comma 2. So let's see here, this is 1/2, half of that is a fourth, half of that is a 16th. So half of one of these little mini grid lines is a 32nd, and I'm going up 2 here. And then 0, 3 is up here. Negative 1 over 32, 4 is up here, very close to the y-axis. And then negative 1 all the way over here, comma 5 is right there. And then let's graph this kind of distorted version of the function. On this problem, they want us to write a rule for f after it has been transformed with the things that they're mentioning here. So we're going to take this one transformation at a time and just do a different function for each one. First thing they wanted was a vertical stretch by a factor of 2. So I'm going to create a g function that does that. And g is just going to be 2 times the f function. That gives us that vertical stretch. Since this is the f function here, we're just doing 2 times parentheses radical x plus 3. So that's going to be 2 radical x plus 6. Next up, to do a translation of 2 units up, I need to do plus 2 to the g function. So that's what my h function is going to look like, just the g function with a plus 2. So that's all of this stuff that was the g function, plus a little 2 outside. That just changes this to 2 radical x plus 8. For this problem, they want us to write a rule for g that's a transformation of f. So I'm going to do this in a couple steps. So g is just f of negative x. So it'd probably be helpful to figure out what this looks like if I plug in negative x for x here. So all these x's will get negatives. The negative x squared is just positive x squared, whereas this 10 times negative x becomes a negative 10x. the cube root is going to stay the same. So this whole thing here is f of negative x. Now I just need to do 1/4 times that and then add a 6 outside. So this whole thing just kind of replacing it in here. And there isn't really much else I can do, right? I can't really distribute this, and this 6 is where it is. I can't move it inside. So this one's done.